This is the lesson for 6.1. It is a review of rigid transformations. We are going to start with our learning objective as always. I can transform a geometric figure using rotations, reflections, and translations. This entire lesson should be review from 8th grade. Now, I know not everybody had the same 8th grade experience. I understand that, so I want to make sure you have this background information before we move on from it. You will need to know it for the rest of the unit. So we're going to go ahead and go over it. Now, this page has a lot of information. This is essentially the review that I used with my 8th graders last year at the end of a unit. So this is basically an entire unit's worth of information, but it should be review. So let's go ahead and get started. So the first thing I want you to do is to watch the YouTube video that I posted of the TED Talk. It's called Pixar, the Math Behind the Movies. So I want you to go ahead and pause this video, switch to that one, and go ahead and watch it first. Okay, so hopefully you were able to watch that TED Talk with Tony DeRose. I'm not sure what his title is. I think he's like the president of Pixar. But he talks a lot about how they use math at Pixar. This whole unit about transformations is very real world applicable. They do use all of this in computer animation. They also use a lot of it in construction, any type of architecture, design. They use these concepts. So this is one of the most real world applicable units we will talk to you about. And it's not like we have to teach you this so we can get to this next thing and then you can use it in the real world. This is the math that's used in computer animation that you are learning right now. So we've been talking about transformations. We keep using that word. So let's go ahead and define it. So to transform a shape or figure means to change it. The example I talk about a lot in class is the Transformers. Bumblebee, he starts as this little Volkswagen Bug car, and then he transforms into this tall, giant robot, and then eventually he also transforms into like a Lamborghini nice car or something. Sorry if I'm wrong. Okay? And all of that is a change, right? He changes from one shape to another. Okay? And when we transform things in math, we can change the size, location, and direction the shape faces. Okay, we can change several things. The shape or figure before the transformation, I want you guys to go ahead and circle the word before. The shape or figure before the transformation is what we call the pre-image. Or some people call it the figure. I never will, but it's in your notes just so you're aware. And we usually label it with a letter. This one says A. Okay. Now, the shape or figure after the transformation, I'm going to do the same thing. Go ahead and circle the word after. The shape or figure after the transformation is called the image, or the new figure. So let's examine these words here. What is an image? What does that word mean? In class, we talked about how that's like a picture. Okay, an image is a picture. And the word pre means before. So this means before picture. It's the before picture, it's the before image. Okay, that's why that word got circled. The before picture. And the after, we just call the image. We just drop the pre off. Okay. Now when we do that, when we have transformed it and we get our image, we would label it like this with an A and then an apostrophe. So that's because this one was A, so this one's also A, but this time it has an apostrophe on the end. We read that as A prime. Okay, this we label or read with the word prime. So we would say A prime. So for example, let's go ahead and label these. So if this says A and this says A prime, then that means that this one is the pre-image, it's the before, and this one is the image or the after. Okay. All right, one more vocabulary word we're going to talk about really quick here is the word congruence. Now, congruence is not one that you guys probably have seen before, okay? You can break down the stems of this word, but I don't know how much that's going to help you. So, congruence refers to whether or not a figure has the same size and shape after a transformation, okay? So, if the pre-image and the image are the same size and shape, we would say they are congruent. They're the same, okay? So, like, we'll talk more about that in a little bit, but if it doesn't change the size or shape, the transformation is congruent. So, transformation is the big word, and then there are more specifics underneath it. So, like, for example, if you were just to say, I'm in the band, okay, that's pretty general. It tells us you're in the band. Whereas if you said, I played the trumpet, that's more specific. You play the trumpet in the band. Trumpet is part of the band, but it's more specific. So these that we're going to talk about right here are all transformations. They're just a little bit more specific. These are all transformations. So a translation is the first one we're going to start with. Okay. So a translation moves every point of a figure the same distance and the same direction. Okay, so this in the video you watched with the TED Talk with Tony, he talked about this with Woody. Woody slid across the stage. He moved across the stage. Okay, so it can move left and right like Woody did, or it could move up and down, or both. It could move left and down. It could move right and up. It can move any of those combinations. That's fine. So let's look at a visual here. So this one on the far left is a translation. So let's go ahead and label this one. So our pre-image is on the top right here. So let's look at some specifics. So this left eye here moves to down here. So if you were to draw a line of how it's moving, you would draw it from there to there. I'm going to move it a little bit. Okay. We can also look at a different point, for example, the right eye, and it moves down here. And you'll notice I'm actually going to copy and paste this arrow. And the reason I can do that is in a translation, it's going to move the same distance and direction. So this one should be an identical arrow to get it there. They should be the same length. Okay. So keywords with translation are slide. We pick it up and slide it over. Okay. We don't change anything about it, we just slide it over. So we talked in class about the word translation and what that means. So a translation can be something as easy as I slid the paper across the desk to you. We moved the same paper, just slid it across to you. Okay. Elevators are a great example of translations. You get it on one floor, it moves you up or down, and you get out on the same spot, but on a different floor. Okay, those are also a great one. Another one that gets brought up always is translating between two languages. So I'm going to use Spanish because I speak a teeny tiny bit of Spanish. So the word apple in English is manzana in Spanish. Apple, manzana. They both mean the same thing. Now, when we translate from one to the other, we don't change the object we're talking about. The object stays exactly the same. The way we say it changes. In other words, you could think of it like this one's the English apple, this one's the Spanish apple, or vice versa. It doesn't matter. Okay? There's still an apple, but one of them's in the English quadrant and one of them's in the Spanish quadrant. Okay, that's one way you could think about this if it helps you. Okay. All right, next transformation. We're going to talk about reflections. So if you think about the word reflection, where do you hear that in your life? What's an example of a reflection? So hopefully you were able to come up with a mirror, okay? A mirror reflection. So a reflection flips a figure over a line of reflection. We'll talk more about the line of reflection in just a minute. In order to create a mirror image. Each reflected point of the figure should be the same distance from the line of reflection, but on the opposite side. Okay. So let's go over here. This one is our reflection. I want you to label your image and pre-image again, so go ahead and do that. Okay. Now I also want you to label something else on this one, and that would be the line of reflection. So I'm going to go ahead and put it here. This is our line of reflection. Okay. So one of the questions I always ask in class is, how do you know that that's a reflection? And students have a really hard time being able to explain that to me. Okay, so I want to show you. So here's the eye that's open, and it ends up here. So it goes from here to here. Yeah, I'm going to do that differently, sorry. So it goes from here to here. Okay. And this line of reflection is in the middle. Okay, this is like what he was talking about in the video when he was talking about midpoints. This would be the midpoint between the two. And you can say the same thing for the winking eye here, from here to here. That's going from here to here. And same thing, that should be in the middle. Okay, this dot right here should be the midpoint or the middle. Okay. Now, part of how we can tell it's a reflection is the location of the eyes, right? So the purple eye, the winking eye, stayed on the outside. It was on the outside here, and it's on the outside here. So it went from being the left side to being the right side. The inside, they stay inside here, right? But this was the right side, and now it's the left side. So it flips around that line of reflection. Okay. So keywords for reflection would be mirror or flip. Okay. All right. Next transformation is a rotation. So in a rotation, let's think. What is a rotation? What is something that rotates in your life? Okay. Most of the time I was getting the motion from kids on their hand, like they were showing me a rotation with their hand. Okay, so one that I see a lot is when, like on a lock, like on your gym locker, right? The lock spins around like this. That's a rotation. So a rotation is when it spins a figure around a fixed point called the center of rotation. So let's dive into that one a little bit more. Let's come over here. So we want to label this as our rotation. And I also need you to label your image and your pre-image. Okay. Now, rotation. It spins around a point called the center of rotation. So Let's dive into that a little bit more. On this one, the center of rotation is the origin. Okay. Now, with the center of rotation, there's always going to be a circle around that center of rotation. Okay. And I'm going to try to get this where I need it. So it should be in the middle of the circle, just like that. Okay, so that's the center of rotation and the circle that goes around it with it. So with this one, let's look at the sunglasses. So in this one, in the pre-image, they're kind of like up and down, right? Now when we rotated it or spun it, they ended up right side up. We could rotate these sunglasses anywhere on this. See how it follows this line? We could follow the line to a different spot too. You could keep going on it, or you could go the other direction. We could come over here, okay, and the sunglasses would essentially end up looking something like that. Okay, I am not an artist, I apologize. But it would look something like that, and then you'd have like the head around it. And then, let's see, something like that. Here, even better, I'll just make it the right size. Okay. And you could even do the little grin. Okay, it would go kind of like this if we were to rotate it, right? Nope, that's wrong, I'm sorry. Rotation would look like that. So with rotation, the key word would be spin. All right, last transformation we need to talk about is a dilation. And I'm telling you right now, we're going to talk about it, and we really won't use it for the rest of the unit. So with a dilation, it is a transformation that either enlarges or reduces the size of an original figure. So a dilation in real life, the most common example students give me is your eyes. The pupil of your eye dilates depending on how much light it's letting in. And what we mean by that is it gets bigger or smaller. So enlarges is the word we use for bigger, and reduces is the word we use for smaller. Okay. So let's go over here. I'm going to call it a dilation. Label your pre-image and your image. And the keywords for this one would be either enlarge or reduce. So it's just making it bigger or smaller. So like from here to here, it's getting smaller. Okay. He talked about that a lot in the video with scaling. He talked about scaling quite a bit. Okay. All right. So I'm going to bring it back up here to the congruence. Okay. Congruence refers to whether or not a figure has the same size and shape after a transformation has been done to it. So I'm going to kind of put this in orange so you guys can see it. So congruence, this one, same size, same shape, it just got moved over. That one is congruent. This one, same size and shape, it's just been flipped over. This one is also congruent. So you would say A is congruent to A prime. B is congruent to B prime. On this one, same size, same shape, it's just been turned. So C and C prime are congruent. C is congruent to C prime. Now on this one, these are not the same size. They are the same shape, they're still a smiley face, but these are not the same size. So this one on the end is not congruent. Okay. The only one that's not congruent is the dilation. Okay. All right, so now that we've talked about some of those definitions, we need to make sure we know how to use them. So I want you guys to tell me, how do you get from figure A to figure B? Which transformation do you use? Remember, these are your choices up here: translation, reflection, rotation, or dilation. There's only one of each. So how do you get from A to B, B to C, C to D, and also from D to E? Which transformations do you have to use to do that? So go ahead and pause the video and fill that out. Okay, hopefully you were able to get that. From figure A to B is a reflection. Hopefully you noticed how A is pointing this way and now B is pointing the opposite way after it's been reflected. B to C is a rotation. Okay, it rotated down here, flipped up now. From C to D is a translation, it just moves over. Okay. And figure D to E is a dilation, it gets bigger. Okay, now, last little example from these notes. So given the pre-image of point A at 5, 2 on the graph, find the location of the image point if point A is, we got to do different things to it. So the first one it wants us to do is it wants us to reflect it over the x-axis. Okay, it wants us to go over the x-axis. So the first thing I want to do is make sure you guys know, where is the x-axis? Go ahead and make sure you're pointing to it on your paper. Where is the x-axis? Okay, it's right there. So the way you can do this, like this one was a little bit easier, right? We just had to say what had happened. This one, they're going to tell us what happened, and then we have to actually do it. So the easiest way to do this is to look at A and say, okay, how would I describe where A is from this line of reflection? If I knew where the x-axis was, but I didn't know where A was, how would you tell me to get there from the x-axis? Now, hopefully you said, oh, Mrs. Boyce, you would just have to go up 2 to get to A. Well then, to get to A prime, we want to do the opposite. So we're going to want to go down 2. So we're going to go back to the line of reflection, go down 2, and that's going to give us our A prime. Now it has been reflected across that x-axis. Okay. Next one, we want to reflect over the y-axis. So you show me, where's the y-axis? Okay, hopefully you knew it's right there. Okay, same thing. So from the y-axis, how do I get to point A? So you got there by doing right 5. So we need to go left 5. I'm actually going to put this over here. Okay, so same up and down, but then we go left 1, 2, 3, 4, 5. And that's where we put our new dot. And this time it wants us to call it B. Okay. For the next one, it wants us to rotate 180 degrees counterclockwise. Okay. So, oh, oops, wrong button. That one. Okay. So we want to rotate 180 degrees counterclockwise. Now, counterclockwise would be going this direction. So I'm going to teach you a way to do this that's really hard to show on screen. So try really hard to follow my words, and if you're confused by it at all, please come see me. So I want you to take your paper, and I want you to rotate the paper 180 degrees counterclockwise. So basically you turn it once to the left, so it's up and down now, and then once more to the left, so it should be upside down. Okay, so your paper should be upside down. Okay. Now, if your paper's upside down, you should be able to go from the origin to point A. And I want you to like make directions of how you would tell somebody to get there. So if it's upside down, you'd be going left 1, 2, 3, 4, 5, and down 1, 2. Okay, so right here, you're going to make a little note to yourself that you went down 5 and left 2 in order to get there. Oh, I flipped those. I'm sorry. Left 5 and down 2. Okay, now you're going to turn your paper back normal, right side up, okay? Now from the origin, you're going to follow the directions you just wrote yourself. Left 1, 2, 3, 4, 5, and down 1, 2. Put your new dot. And it wants us to call that one C. Okay, now I know that was kind of confusing, so we're going to do another example. So this time, we are going to rotate 90 degrees clockwise. Okay. So remember, clockwise is this way, and 90 degrees is only once. So I want you to turn your paper to the right, okay? Turn your paper to the right, and then from your origin, count your directions. So we're going to go right 2, and down 1, 2, 3, 4, 5. So we're going to go back here, and we're going to write right 2, and down 5. Then you're going to turn your paper back to its original position. From your origin, you're going to count right 2 and down 1, 2, 3, 4, 5. And you're going to put your dot there. And it told us to label this one D. Okay, so with these, I hope you guys can kind of see the circle that's happening here. So your circle should be centered on your origin. So I need to kind of adjust mine a little bit here. Okay, should be centered on your origin. And it should be going out to these points. Okay, should be rotating along that circle. And I think that mine is not big enough on the paper to be able to really properly show this to you, because when I put it on all 3, it is not at the right center. So I apologize in advance that that's not doing what I really want it to. I can't quite get it big enough. Well, maybe there. Did I get it? Okay, there we go. That's a little bit better. It's still not perfectly centered. I'm sorry, I don't think the graph is perfectly square, which causes problems. But you can see that all of these points are around this circle of the center of the rotation. Okay, so again, remember, with reflections, we have the line of reflection, so the x-axis and y-axis. With rotations, we have a center of rotation, and in these cases, they were both centered around the origin. Okay, now the last one I think is the easiest one, so I'm going to leave you to do it on your own. If you have any problems translating, let me know. My completed notes are on Canvas, so you should be able to see it there. But go ahead and do this last one and let Mrs. Boyce know if you have any questions.